Hello everyone, welcome to your YouTube channel where we talk all about the GATE exam and we are studying operating system, process management. So in this video we are going to understand the various process times in the process life cycle. So various process time in the process life cycle, when a process gets created and the time it gets terminated, from creation to termination, it goes through various states in your state transition diagram. That entire life cycle is nothing but then a process life cycle. So when a process is being into various states, different timestamps are attached to its instance, which probably are utilized when we make CPU scheduling algorithms and we make its analysis in terms of different time calculations. Also, when you find out the throughput or the efficiency of the system, when you're trying to find out the average waiting time, these all are kind of analytical work which we understand to know which algorithm gives us what performance, which algorithm gives us what performance. So the various times related to a process are arrival or the submission time, the burst time, which could be further categorized as CPU burst time or the input output burst time, wait time or the waiting time, turnaround time, response time, and the completion time. So I'm going to explain all these times along with the STD diagram, state transition diagram. So let's start with the very first one. So let's suppose that we have a process P1, which arrives into the system. So it got created at the new state, correct? The process P1 got created at the new state. From there it is released to the ready queue. So it comes into the ready queue. So the moment of the time when the process P1 is coming into the ready queue for the first time, okay, so that is arrival into the ready queue. So that time, that particular time T, suppose it is T0, so that time T0 is known as the arrival time of what? Of P1. So the moment of time any process comes is arriving into the ready queue or is submitted to the ready queue is known as the arrival time or the submission time of the process. So this is the moment of time the arrival time comes into the picture. The next time is the burst time, which comes into two categories: CPU burst time and the output burst time. Simple, the amount of time process needs for its execution part. Whatever piece of code the process has come up with in your process address space, I told you the code section is there, text section there, so it has instructions to execute. The amount of time it needs to execute its instructions is known as the burst time. Now, CPU burst and input output burst, why two categories? The CPU burst and the input output burst simply says amount of time you need to run your instructions on CPU, when you need the resource CPU to execute your instructions, and the amount of time you need to make access of some input output devices, the peripheral devices. So I mean, somebody might say in that case also CPU will be somewhere involved because control signals will be generated. Absolutely correct. But this is exclusively for the CPU and this is exclusively for the input output operations, and of course we do not get into very minute details, but still we can categorize for the input output peripheral devices whatever time is required, that becomes the input output burst time, and exclusively for instructions to get executed on CPU we need the CPU burst time. Alright, and the most of the time the burst time given in your problems will be nothing but then the CPU burst time. Okay, so that becomes, so now when the process is in your ready queue and it gets scheduled, it gets dispatched to your CPU, so it is running on CPU, so the amount of time your process P1 is performing here, the amount of time it is spending on this CPU is nothing but then this CPU burst time. When the process will come here and it will be given the execution of the input output, that will become its input output burst time. Okay, so this is a place where we also call that it is a blocking state or the wait state. This is also known as. So yes, when a process comes here, it does not immediately get the execution on the input output. It might have to wait in the device queue. So that waiting time will be counted in the wait time, but the time it will get chance to execute the input output, that will get counted as input output burst time. The next time is wait time. The total amount of time your process is waiting, either in the ready queue or in the input output queue. Okay, so either you are waiting for some event to occur, or you are waiting for the access of the input output device, or you are waiting sitting in the ready queue to get the chance on the CPU. So even if your like time quantum is over or some high priority process comes, so you are given back into the ready queue, so the amount of time your process is waiting here is counted as wait time. Okay, so here also wait time, and amount of time you are waiting here is also counted as wait time. So yes, when you are accessing device, it comes out IO burst time, but when you are waiting for the IO device, that comes out to be wait time. I mean, see, this is just an idea for you to actually visualize how actually these times are counted. I mean, I could just simply omit this part and could come up with a definition and would have just said in one more line, okay, this is the time, this is the time, this is the time. Even that was understandable, but this, I believe, will clear the picture in a better way. So the next time is a turnaround time, but I will come to it after the completion time, because it needs to have the understanding of completion time. So let me explain you what is the completion time. So the process comes into the ready queue, goes for the running, goes for the input output, and comes back to your ready queue, then goes back whatever number of cycles it has to make. Finally it gets over and it gets terminated. So the moment of time, the instance of the time when it gets terminated, it gets complete, all the resources get deallocated, that time is known as completion time. So here is your completion time for the process. Alright, so what the response time is? Very simple. When a process is coming into the system, it's coming for performing some task, right? It wants to execute some instructions. The very first moment when a process gets a chance on the CPU and it executes some of instructions and produce its output, the very first instance of output, that becomes a response time. So that simply says whenever a process is producing its first response to its user, the user who initiated the process. So the very first response initiated or given to the user by the process is known as the response time. And also it is said that the response time is a performance metric. Why? Because response time shows that how much time a process has to wait before it actually starts executing. Correct? We do not want any process to just keep on waiting without any of its execution chance. So that's why we say that response time should be less. Less means a process should get a quicker chance to start its execution, right? So fine. So this is also done. Now finally the turnaround time, which is a very important performance metric, which is quite used to analyze the performance of a CPU scheduling algorithm. Turnaround time in very simple manner is the total amount of time a process waits in the system, either executing or waiting. So waiting time plus execution time, that total amount of time is nothing but then the turnaround time. So I can say that turnaround time is nothing but then the burst time plus the wait time. Okay, I could say at the completion time it got turned off, and at arrival time it got initiated, it got created. So completion time minus the arrival time also gives me nothing but then the turnaround time. So the amount of time or the moment of time, so the moment of time the process comes in your system and makes its arrival. Okay, after that whatever processing it does, fine, the moment of time it goes back, okay, it gets completed. Okay, so the difference between this to this is nothing but then the turnaround time. So next, let's start understanding the CPU scheduling algorithms one by one, where we are going to make use of all these times quite frequently, and we are going to make calculation based upon them. So please be sure that you know all the times. If at all you have any doubt, please put them down in the comment section. I'll see you once again very soon. Till then, bye bye.